It's time for a new episode of my Linux driver tutorials. Last time I've shown you how to write a better Hello World Linux kernel module. But what is the purpose of a driver? Well, a driver should access some hardware, and our Hello World kernel module didn't so far. So today I want to show you how to access one of the easier hardwares available on an embedded system, which are the general purpose input-output pins or GPIO pins. So the goal of today's video is to control this LED and this push button from a Linux kernel module or Linux driver. Okay, but first let's take a look at the GPIOs which are available on the Raspberry Pi. So the Raspberry Pi has this 14-pin pin header, and each pin which is labeled with GPIO can be accessed or can be used as a digital input or output pin. If we want to see the GPIOs which are available in our system, we can also connect to our Raspberry Pi and run the GPIO detect command. So this will search for the available GPIOs, and we can see here we have GPIOs are organized in GPIO chips. So we have GPIO chip 0, which has 54 GPIOs available, and we have GPIO chip 1 with 8 more additional GPIOs. And the one which is connected to the pin header is this GPIO chip here. This is, here we can see the driver's name, and this is the Broadcom 2835 pin control driver, which controls the GPIOs. So let me navigate into my Linux driver tutorials folder, and let me copy the sources of our better Hello World kernel module and create a new folder I will call GPIO control. Then let's navigate into this folder and let's take a look what's in here. So we have the source of our driver, some makefile to build it, and a readme which will give you some additional information. First thing I will do is I will rename the source file from hello.c to gpiocontrol.c. And then of course I have to change this in the makefile as well. And then we are almost ready to go. But we have to talk about two things first. The first thing is, to make this video a little bit more easier and accessible, we won't use the standard way to add GPIO or to use GPIO in a driver, because a standard way for an ARM-based system would be to add the pins over the device tree. But as the device tree is a little bit complicated, I will do videos about it later. I thought let's use a simpler way. And with that said, we can take a look at the hardware setup, which I've shown here in this drawing. So we have a LED connected over a resistor, and here this is the GPIO pin which controls the LED, and this here is GPIO pin 21. And here you can see the button and how it is wired to the Raspberry Pi, and the input of the button is wired to GPIO 20. You can look up the pin numbers here on pinout.xyz for the Raspberry Pi, and you can see here again, yes, we will use these two GPIOs. So each GPIO pin has a number assigned to it, but sometimes this number is not enough to address it. Because you see here we have two GPIO chips available. And if we go into sys class GPIO, we see our two GPIO chips again here. And this number in front here is the offset we have to add to the pins. Okay, but what here is GPIO 0, what is GPIO 1? To find this out, we can cat the label of the GPIO chip. And here we see, okay, this label is matching with GPIO chip 0. So here we are lucky, we need to add an offset of 0. But if we want to use pin 4 of this GPIO chip, for example, then we would have to add 504 and 4 to get the actual pin number to use it within our driver. Okay, so let's go back to our source folder and let's open up the source file for the driver. So for managing GPIOs, we need the header linux gpio/consumer.h. And then I will declare two global variables from the types struct GPIO desk, and they will be pointers. The first one I will label LED, the second one I will label button. And over these pointers we will later be able to control our GPIO pins. And the thing is, the functions I will use to set up the GPIO pins as inputs or outputs, and the functions I will use to read or write to the GPIO pins, they can be used in a device tree driver as well. Only the method how I get these pointers is different. So here what I will do is I will call the function GPIO to descriptor, and in here I have to pass in the GPIO number I desire. And let's use defines for the GPIO numbers. So the IO pin for the LED is 21. The IO for the button is 20. And I will also define the offset we have to add, which is 0 in my case, but maybe it varies on your Raspberry Pi. So by using this offset, you are prepared. Okay, then in here, I need to convert the GPIO number IO LED plus IO offset, and then this number will be converted to a pointer of the type struct GPIO descriptor. And please be careful, this method works well on a Raspberry Pi, but I can't tell you for sure that it will work on any other embedded system or on an x86 system. So if you're using another ARM-based system, yeah, you can try it, but it would be better if you wait for me to do the video about how to add or use GPIOs over device tree. Okay, so in case this returns a null pointer, we couldn't get pin 21. And I will print out a message to the kernel's log. So I will print out GPIO control error getting pin 21. And I will return the error code error no device. And then I will do the same thing for the button. And now here I have to use the number of the button. Okay. Now we have a pointer to our GPIO here in our struct GPIO descriptor, but we have to set them up and then we can use them. And I will declare a status variable here for saving possible error codes. And now I will call the function GPIOD direction output to set the IO pin LED to an output pin. And then the second argument here will be the desired default value of the GPIO pin, and here I will pass a 0. And in case status is not equal to 0, an error occurred. So then I will print out error setting pin 20 to output, and I will return the error code returned by GPIO direction output. Then for the input I will do something similar, but here the function is called GPIOD direction input, and in here I only have to pass the pointer to my GPIO descriptor. And let's adjust the error message as well. Okay, so now we can set the GPIO, and therefore I will use the function GPIOD set value. And as arguments I have to pass in a pointer to my GPIO pin and the desired value. And then let's read out the button. Button is pressed. And for reading the value, I will use the function GPIOD get value, and here I have to pass in the pointer to the GPIO pin I want to read out, which is button. And this will return a 0 if not pressed or a 1 if pressed. So in case this returns a 1, I will add nothing here as a string, and in case it returns 0, I will add a not here. Okay. And in the exit function, what I will do is I will set the LED back to 0. And then last thing I will do is I have to change the description to an example for using GPIOs without the device tree. Okay, cool, then let's try to compile it and run the program. Let's see if I made some mistakes here. Yep, I did. Let me double check. Static struct GPIO. GPIO descriptor, not GPIOD descriptor. That's the error. So let's run it again. Now it's looking good. And now let me spawn a second terminal here. And here we will take a look at the kernel's log. Okay, then are you ready for loading the module? So, and now we can see that the button is now pressed and the LED here is on. If I remove the module again, the LED turns off, and now let me press the button and load the module again. Then we get here the message button is pressed and the LED is on again. Okay, cool. That's how to access GPIOs from within a Linux kernel module. But this currently has one downside. So we can control the state of the LED and we can read out the button, but only when we're loading the module or when we're unloading the module. But it would be cool if we would have an interface from userspace over which we can control the GPIO and the button from our driver. And in my next videos, we'll talk about one possible interface and how to implement it. Okay, cool. So I guess that's it for today. I hope you've enjoyed the video and learned something. In case you want to support my work, you can buy me a coffee on buymeacoffee.com/journalsforlinux. So thanks for watching and goodbye.